Hello my dear students, how are you? Today I am going to deal very important organic conversion. So that is very important for knowledge as well as what you see examination view of point. So what you see important organic conversions. So for this, at first we have to know some tools. Tools for doing organic So for conversion of any organic compound, methane to ethane, ethane to methane. So for this we need some what we see tools for doing organic conversion. So first rule is like this. So at first alkane is converted into alkyl halides with halogens. Halogens means maybe chlorine, maybe bromine, maybe iodine. So at first, always for what you see doing organic conversion, so at first alkane is converted into alkyl halides with halogens, maybe chlorine, maybe bromine, maybe iodine. Yes. So example are like this. So what you see CH4 plus, suppose we talk about bromine when heated. So what you get? CH3Br plus what you get? HBr. Minus HBr means, so what is the liberation of this HBr? Minus means it gives also HBr. Now we have to, at first alkane halide is converted into what you say alkyl halide. So what you see CH3Br plus what you see HBr. So that is known as alkyl halides. Yes, first tool. So alkane is converted into alkyl halides with halogen. Halogen may be chlorine, maybe bromine, maybe iodine. Yes. Second rule is what to say alkyl halide is converted into alcohol with aqueous. Aqueous means solution made in NaOH, or we can say KOH. So alkyl halide is converted into what's alcohol with aqueous NaOH KOH. We must know all these. So what is suppose C2H5 bromide, that is we can say bromo ethane when that is treated with aqueous maybe NaOH or OH solution, we can use any. So what we get? So that is nucleophile, that is electrophile, you know. So that Br is substituted by this what you see nucleophile. So what type of reaction it is? What you see nucleophilic substitution reaction. Yes, so what do we get? C2H5OH plus what you see side product is sodium bromide, that is ethanol. That is ethanol. So first, always keep in mind at first alkane is converted into any alkyl halide. Then already the example over here. Second one is alkyl halide is converted into alcohol with aqueous NaOH or KOH solution. So what you see, the NaOH solutions, what type of reaction it is? Nucleophilic. That Br is substituted by this nucleophile. So that is known as what you see, nucleophilic substitution reaction. Third one is alkyl halide. Generally, alkyl halide is converted into alkene by alcoholic solution of maybe sodium hydroxide, maybe hydroxide by dehydro. I have already taught you dehydrohalogenation reaction. So look at over here. So alkyl halide. So suppose C2H5 iodide, that is iodoethane. When that is treated with alcoholic solution made in alcohol is known as alcoholic, maybe NaOH or solution. So when it is heated, process is what you see, dehydrohalogenation. So removal of hydrogen as well as halogen, you know. So what do we have? CH2 double bond CH2 plus Na sodium iodide plus H2, that is known as ethane. Yes. So for conversion of alkyl halide into alkane, always we have to treat with alcoholic, maybe NaOH, maybe KOH solution. Fourth one is primary PRI, primary alcohol, that is also known as first degree. Alcohol is converted into aldehyde and acid by oxidation with acidified solution. So maybe potassium dichromate, maybe potassium permanganate, MnO4. Yes, you can use either potassium dichromate or you can use what you see, potassium permanganate. So what you see over here? So at first we have to know primary alcohol. Yes, the primary alcohol is so RCH2OH, that is known as primary alcohol. So always keep in mind. So if one alkyl group is CH2OH group, that is known as primary alcohol. So when that is oxidized, that nascent oxygen come from the what you see, acidified solution of potassium dichromate. H plus means acidified. So process is what you see, oxidation. So at first what to get? Aldehyde, and side product is what you see? Water, and that aldehyde again further oxidize same reagent K2Cr27 S plus oxidation. So what you get? RCOH, that is known as acid. Yes, that is the general. That is the general reaction. So for example is like this. R means we can take any. So some simple one is CH3 CH2OH. That is ethanol, ethyl alcohol. So when that is oxidized, same reagents, what we have? At first CH3, so that is ethanol. Aldehyde group over here. So what you see? Aldehyde, ethanol. When this is further oxidized, so what we have? CH3COH. That is ethanoic acid. To convert from what you see alcohol to acid, always we have to acidify it with maybe potassium dichromate, maybe potassium permanganate. Yes. That is primary alcohol. Next one is secondary. Secondary alcohol is oxidized into ketone with acidified solution of potassium dichromate or potassium permanganate. So what is this secondary alcohol? So we have to know what is secondary alcohol. Secondary alcohol, so what do you see? If general formula RRCHOH. So H is decreasing, R is increasing, R is alkyl group. So that is secondary alcohol when oxidized with potassium dichromate. So what is the reaction is oxidation. So what you get? RCOR, that is known as ketones. For conversion of what you see ketone from secondary alcohol to ketone, what reagent we have to use? Acidified solution of potassium dichromate, that is the general reaction. Example is like this. CH3 OH, carbon must be tetravalent. So what the name of this compound? How many carbon? 1, 2, 3. Propanol. Yes. So when that is oxidized with same potassium dichromate, so what we have? CH3 CO CH3, that is known as what we see? Propanol. Yes. So secondary alcohol is converted into a ketone, or primary alcohol is generally converted into the aldehyde as well as what you see? Acid. Next one is what you see? Primary amine. Primary first degree. Amine is converted into alcohol with nitrous acid, that is nitrous that come from by the reaction of sodium nitrite plus dilute HCl at low temperature 0 to 5 degrees centigrade. 0 to 5 degrees centigrade, you can say low temperature. So, what you get? Nitrous acid plus what you see? NaCl. So, we cannot use directly nitrous acid over here. So, for the what you see conversion, we need nitrous acid. That nitrous acid is reacted what is obtained by the reaction of sodium nitrite and dilute HCl, that is dilute HCl. So, what you get? Nitrous acid. Look at over here. So, what we say? Primary amine RNS2, that is known as first degree. When that is treated with HNO2, that come from the reaction of sodium nitrite plus HCl 0 to 5 degrees centigrade. So, what we have? Alcohol, that is the alcohol plus H2O plus nitrogen. Yes. So, example is, that is the general reaction. Example is like this: C2H5NH2, that is C2H5. So, what is the name of this compound? Ethylamine. When that is treated with nitrous acid, same reagents, what we have? C2H5OH plus H2O plus N2, that is known as ethanol. Yes. So, we cannot convert methane primary amine into alcohol. Exception: methylamine. You cannot convert methylamine into alcohol. Yes. Next one is number of carbon in chain is increased by either Wurtz reaction, Wurtz reaction, or converted into alkyl halide, alkyl cyanide, or converted into alkyl cyanide with cation. Cation means potassium cyanide. So, look at over here. So, what do you say? CH3. So, suppose CH3Br, Wurtz reaction, sodium, so what is it? Dry ether, sodium, metal. So, what do you get? 2Na. So we get C2H6, that is ethane, plus side product is what you see? NaBr. Yes, so that is in this case first carbon, but in this case what is C? 2 carbon over here. Like this, CH3Br reacted with what you see? Potassium cyanide, maybe alcoholic solution. So what we have? CH3Cn plus KBr, that is methyl cyanide. So two ways by which we can increase the number of carbon in chain. First one is Wood reaction, you know, very important. Next one is CH3Br when treated with alcoholic KCN, what we get? Methyl cyanide plus KBr. Sometimes you have to decrease the what you see carbon. In this case, next one is for decreasing carbon atom in chain. Decreasing carbon atom in chain, we use Hofmann, H-O-F-F-M-A-N-N, Hofmann degradation process. Hofmann, name of the chemist. So look at one example over here. So what do we say? RCONH2, that is amide. When that is treated with what do we say? KOH, potassium hydroxide, bromine solution. So what you get? Always removal of what you see? CO group, and that is also known as decarbonylation. That is also known as decarbonylation reaction. You can say removal of CO group is known as decarbonylation. So what we have? Primary amine plus KBr plus potassium carbonate plus H2O. Yes, so what do you see? In this case, one carbon is what you see? Removal at the form of CO group. So decarbonylation, that is removal of CO group, you can say. So these are the important tool conversion of any chemical equation. Yes. So for example, is like this. How to convert? So these all are the tools by which we can convert all the what you say organic compound from lower to higher, higher to lower, like this. So first one is methane to ethane. Yes, methane to ethane. So we have to go from methane means what you see? CH4. So at first we have to convert it into what you see? Alcohol, what you see? Halide. So use general Br2. When heated, so what you get? CH3Br. And one product is what you see? HBr. Minus means what you see? Removal. So what you get? Methyl bromide, that is methyl bromide. When that is Wurtz reaction, for increasing the carbon atoms, so what we use? What we say? CH3Br, dry ether, that is also known as Wurtz reaction. So what we get? C2H6, and side product is what we see? Sodium bromides. Yes. So we have to only write down the what we say condition as major product. Not need to balance over here. Not need all the what's the side product in this case. Not language. Yes. So if you ask in examination, so how can you convert methane to ethane? So we have to convert like this. At first, methane is converted to alkyl halide. That is what's Wurtz reaction, you know, by increasing the carbon atom. What we have to do? Wurtz reaction. What we get? C2H6. Next one is ethane. Ethane to methane. Now higher to lower. So what do you see? At first, converted into halide. So what do you get? C2H5Br, and side product is HBr. So we have already studied about the what you see alcohol. So when that is treated with aqueous sodium hydroxide solution, so what you get? C2H5OH, that is known as ethanol. Yes, and side product is what you see? Side product is sodium bromide. Yes. Now this is oxidized. I have already told you. This is oxidized. K2Cr2O7 acidified solution. So what you get? CH3COH, that is ethanoic acid. Now this is treated with soda lime. Soda lime means mixture. When heated, so what you get? CH4. Yes. What you get? Methane. So how can you see? So in this case, methane to ethane, lower to higher. In this case, ethane to methane. So we have to decrease the carbon over here. So what we have? This has ethane. This is what we say? Methane. Yes. Now third one. Third one. Ethane to ethyne. Ethane to ethyne. So that is single bond, that is the triple bond. So what we have? C2H6, that is ethane. When that is treated with bromine, iodine or chlorine. So when heated, so what we have? C2H5Br, and side product is what we see? HBr minus. So when that is treated with alcoholic KOH solution, when heated, so what you get? CH2 double bond, that is known as ethane. Alkane single bond, ethene double bond, and side product is what you see? KBr, and what you see? H2O. Now from ethane, So that is treated with same what you say bromine. So what you get? Yach. The name of this compound is 1,2-dibromo ethane. Now that is further treated with alcoholic KOH solution heated. So what we have? C triple bond H. That is known as ethane. So what is ethane to ethene? Sometimes ask you write down the conversion from ethane to ethene goes up to. Sometimes ask you write the conversion from what is ethane to ethane, then we have to go up to here. Yes? So that is ethane to ethine. Next one is ethine to ethane. Triple bond to single bond. So what we have? C triple bond, that is ethine. When that is hydrogenated in presence of nickel catalyst at 250 to 300 degrees centigrade. Process it, hydrogenation. Hydrogenation means addition of hydrogen is known as what you say? Hydrogenation. So what product you get at first? Yes. So at first triple bond to double bond, what you get? Ethene. Now that is further treated with H2O. So what you get? H2 reagent is same, nickel catalyst 250 to 300 degrees centigrade. So what to get? H. So in this case 2 pi bonds, 2 times what's the addition over here. In this case 1 double bond. In this case no double, what's the pi bond. So there is no further addition. So that is ethene, that is ethane. Ethine to ethene, ethene to ethane. What the question in asked the examination? If only we have to convert ethine to ethene, then we have to go up to here. We have to convert from ethine to ethane, then we have to go up to there. So always keep in mind. One. So, for example, I have already given you. Now, so again, we give you some 8 and 10 example over here. So that is ethine to ethane. So you have to give at least 10 to 12 conversion. Yes. So I thank you for visiting this what you see video, and I also think you have subscribed and also convey channel to another friends for learning. Yes.